Today we invited two guests, two speakers, to discuss about how deep learning is being applied to disrupt industries. Long Yu and Aleix Ruiz de Villa are telling us how they apply deep learning in the fashion retail industry and in the knowledge management industry to categorize contracts or to categorize fashion items. And I think it's very interesting both from the technical standpoint, what they're going to be telling us, and also from the business implications that it has on how it will transform this industry. So I hope you enjoy the two speakers and what they have to say.
Hi, good evening everyone. Welcome to this new BCN Analytics event. This is the third episode of our machine learning series. You remember a few months ago we said we won't talk about machine learning, not in one event, but in several events. So to keep it easy, we will use, for those of you active in social networks, the same hashtag, BCN Machine. So let me recap a little bit what we've done in the first two events around machine learning. I think we all recognize and we all learn how relevant machine learning is becoming, how prominent machine learning is becoming. In the first episode, what we had is people from BBVA and from Telefónica, and they were sharing with us how they are doing, how they are using machine learning, let's say from a research and development perspective, from an innovation perspective, from big companies. That was the first chapter. In the second, we had a completely different approach. We brought Joan Bruna from, although he's Catalan, he's based in North America, and he was sharing with us his experience from the academia side, right? So his learnings, his views, but also very interestingly, the high-level view on upcoming trends in machine learning and deep learning. So I think it was quite inspiring. And today we want to have a completely different approach, a different angles. The angle we want to take is machine learning, we all know, is disrupting many industries. I think all of you being here already know that. So we said, okay, we want to bring here companies who are really disrupting industries through machine learning. And the good news is that here in Barcelona, and I think we need to be really happy about that, there are several companies who are effectively starting to disrupt industry by using machine learning, deep learning, artificial intelligence. So before getting into that, and we will have two great speakers to talk about this disruption, we have something that makes me extremely happy, which is the Datathon about pollution levels. So I think I was explaining to you guys last time we met in episode 2 that we were organizing this Datathon. Theme is pollution levels, level of our air, the quality of our air, is becoming really, really scary. In fact, this Datathon is part of an exhibit at CCCB called After the End of the World. I was lucky enough to attend the inauguration last week, and I strongly recommend you. It's very telling. It's basically showing how we human beings are pushing the planet to the limit, right? So I strongly recommend you to get there, and if you have a chance, so it's going to be there in CCCB for a few months. And our Datathon is part of this big cycle, this big exhibit. Also, as I mentioned last time, this initiative, and that's what makes me really happy, is not just BCN Analytics, it's a group of organizations really working together. So we have Barcelona Supercomputing Center, we have, of course, CCCB, we have LEITAT, we have Big Data Center of Excellence, and we have also BCN Analytics. So it's different organizations working together. And since last time we met, we have been working to find sponsors for these initiatives because we want to do this for the good, but also we want to have some prizes from the winning teams. So we were lucky to have 4 sponsors. First one is Solaluz. It's a company based in Barcelona, founded by 3 people from Barcelona. And they are really a cool company. They are trying to disrupt the electricity business by doing a sustainable model. So very nice company, and it's a great honor to have them as sponsors. We also have good friends of us, Social Point. They're also a very successful company, raised in Barcelona, now becoming a multinational company. So it's great again to see how a local company can really become an international player. So also it's a great honor to have Social Point with us. Third sponsor is Gauss & Neumann, a very also a cool company. They do SCM architecture, and also they have a strong presence here in Barcelona. So also great pleasure to have them on board because they really believe in trying to do data for good. And obviously to Mobile World Center, because as you will see as prizes, we will have not only money, but tickets for the upcoming Mobile World Congress. So it's great to have local companies or already being, let's say, multinational, really supporting us in this initiative. More details on the Datathon, and I think you all know this. It's going to be on January 20th and 21st. The goal is around enhance an existing model, on predicting the quality here in Barcelona. We have already secured more than 3,000 euros in prizes, so I think it's really good. So for the winning teams, will be a nice surprise. And if you want to register, you are still on time, so you could visit our site, visinaanalytics.com, and we explain there how to register. That to say, right now we have more people registered than available seats, right? So it's still registrations are open, but soon will be closed, and then we will start the selection process. It's a pity that we have to select, but also we want to keep it, let's say, from an organizational perspective, manageable, because we don't want to have, or we don't have the ability to have like 200 people in a room working together. Not just this year, maybe next year. We're already thinking on the second edition, so stay tuned on this. But then this is on the Datathon. So for the session today, as usual, we have our panel. We'll have two speakers, Long Yu from WideEyes, and Alex Ruiz-de-Villa, an old friend, and also working now as Chief Data Officer at ONA. Alex is here. So as usual, we have both of them presenting. And after that, we will open for some Q&A. So Pau will be moderating that session, but then I really encourage you guys to participate and to ask questions, because this is really what we want to accomplish here, is to have a conversation. And then at the end, we will have some time for beers and networking. I remember last episode, so when we were to university, some people after the event was complaining, Manuel, no beers, it was really hot. So this time we are back to, let's say, home, and we are getting beer. So if you just came for the beers, wait until 8:30. And then we need to leave the place really sharp. So at 9 we'll be closed. So probably 5 to 9 we will have to leave the building, just for you to know. So just before starting again, big thanks to our ongoing sponsor, Schibsted. Thanks to them, we are recording this event. And later on, everyone can watch it in YouTube channel. So in case you miss some of our events, you can always go to our YouTube channel and see previous sessions, or even this one, enjoy the best moments. And also big thanks to Mobile World Center. They are sharing this venue with us, so we can come to celebrate these events. And obviously, Estrella Damm, they are bringing the beers that you will enjoy later. So with no further delay, Pau, all yours.
Thanks, Manuel. Thanks, Manuel. Okay, so I'll introduce the two speakers for tonight. And yeah, as Manuel said, I encourage you to be thinking about questions, because I can speak with them for 25 minutes afterwards, but I think it's a lot more interesting and enriching if you guys participate. So let me introduce Long Yu. He's received a master's degree in computer vision and artificial intelligence from the Universitat Autònoma de Barcelona. In the same year that he finished, this is 2013, he co-founded a company called WideEyes that he will be presenting today. That it's about applying artificial intelligence to image recognition. His career as a computer vision and machine learning geek started with human detection of surveillance and face recognition for biometric analysis. And currently, he's the member of the board and head of research and innovation at WideEyes. So basically, the guy's developing the product behind their company that he will describe in a minute. That, as I said, focuses on image recognition and retrieval and object detection in the fashion industry. So with no further delay, I will pass on the word to Long. The floor is yours.
Okay, can you hear me? Okay, I think so. Hi everyone, thanks to Barcelona Analytics and Mobile World Center to invite us at WideEyes to give this first talk in this event. Okay, so I will talk about deep learning in the fashion industry. Okay, we start with test search. Test search doesn't work in the fashion industry. When you type something in the e-commerce, sometimes you cannot find the fashion item that you are looking for. So let's do it in the visual way. So who we are or what do we do? WideEyes was founded by 4 co-founders in 2013 by Luis Manent, Miguel Pousa, me, and Rodolfo. Okay, we started with Similify app, and after that we realized that this visual search is super interesting for the e-commerces, and we deliver this technology as a SaaS. So after that, we developed several products. Okay. So Simplify app allows the users to draw the contour, okay, of the image around the fashion item and find some similar items in some specific catalog. It was the first approach of visual search, and also it was a proof of concept. After that, we realized that it's quite interesting for the e-commerce to allow to users get more engagement in their website and navigate through the several pages by the image. Okay. So we said, okay, so let's deliver this technology as a SaaS, as a business to business. We have several products. One of them, for example, is shop by image. Okay, you are in the street and you take a picture, or you are at home and you have magazine. You say, okay, I like this. The coat is wearing this woman. Okay, you take a picture and draw the bounding box around the red coat, and we deliver give you similar result of similar item to the query. In this case, in the red coat. And also, we offer similar recommendations for the e-commerce website. Okay, the user can navigate through the website and suddenly say, okay, I like this blouse, this blue dress, but it is out of stock. So what will be we can solve? We say, okay, no problem. We offer you similar items. Okay, so user can still navigate through your website and sometimes can purchase, buy another dresses that are similar to the query. Okay. Also, we offer no focus on data analytics, but we offer some insights, some specific tags. In this case, some attributes to the customer. Customer can use, okay, I will use many API calls of your services, and I will collect all the data that you are offering me. For example, this here, the user was looking for this skirt. So we could predict the color is multicolor. I don't know if you can see here, multicolor, almost 95%. It's saying that closest length is long, the silhouette is shift, and pattern types is printed and floral. Okay, and the style is a street style. So for the customer, it's very interesting to collect this data and analyze according to the time. It's like more like a trend analysis, right? So these services were powered by deep learning. So I'm going to talk about the machine learning in the computer vision field. Okay. In the traditional methods, let's say before 2012, the traditional methods were consist of several black boxes like feature extraction and encoding and predictions. Okay. Recently, there is the deep learning method that allows you to do the similar things, but instead of feature extraction, encoding, and prediction, they concatenate the layers one by one consecutively. Okay. I'm going to talk about a little bit of these disadvantages of traditional methods and advantages of recent methods. In the traditional methods, you have to do many parameters of each part of your technology, your system. Okay. But in the recent methods, deep learning, there are predefined architecture you can rely on. You don't have to modify the network. You just put it and say, oh, it works. Traditional methods is not end-to-end. It means that once here you have an image, you fit this image to your pipeline, and you predict some labels, and you try to minimize this error against with the ground truth. And this information goes through the prediction block. Okay, and this system, this part can learn, is learnable, but this information is not transferred back to the encoding part. And this block can now transfer the information to the feature extraction. So here you have to fine-tune manually, and here you can learn a little bit. Okay, but in deep learning is end-to-end system. Okay, here you learn the parameters in order to increase your accuracy, and you transfer this information back to the previous layer, and this one to the previous layer, and so on. Transfer learning is not feasible for the transfer learning is not feasible for the traditional method, because once you imagine that you are a system that is able to classify cats, and you cannot use this system to train classify flowers, for example. You have to start training again from zero. However, in the deep learning, the transfer learning is feasible. You take pre-trained models with some fine, quite optimized parameters, and you just fine-tune a little bit the latest layer, and you can achieve very, very good results, even you don't have you don't have too much data. Okay, and the traditional method, you have many software that run the CPU and many different implementations. You go to the GitHub, you can find many implementations of Shift, Hawk, SVM, and so on. And you can rely on this software because the developer is an individual person. Okay. However, in the deep learning, the computation is performed in the GPU, which is much faster than CPU, and the softwares are backed by big companies. For example, TensorFlow is backed by Google, and PyTorch is backed by Facebook. So this software are developed by big company. You can rely on, and you can use it, and you don't have to worry about it if they have a bug. If you have a bug, okay, just publish it in some community, and they will reply you. So you solve the problem. Okay, so this is the advantages of deep learning. So challenges of deep learning. What happens if you don't have a lot of data? Okay, then you will say, okay, I need money, I need to pay for the data annotation. If you have a lot of data, you can achieve very, very good results. Okay, but once you are here in this curve, even you pay a lot of money here, even you pay a lot of money, it means that you can collect more data, you cannot see the huge increase of the accuracy. So it will be a great idea if you know the human performance. Okay, if human performance is here, for example, and you are very close to the human performance, maybe you will say, okay, I don't have to spend a lot of money in order to increase the performance of my model. Okay. And deep learning is cool, but still require a lot of the efficient code for the training in the high-end machines with GPUs. Okay, because sometimes when you train the neural networks, takes between 1 day and 1 week. If your code is not efficient, maybe it takes 2 weeks, and I don't think you want to wait for 2 weeks. And I think, okay, I wait. No, it's not a good idea. So make sure that your code is efficient. So first you have to have a good code to read the data and pre-process the data in the CPU and run all the neural network training in the GPUs. Okay, so if you are able to run this both part in parallel, will be great. Because you are leveraging all the hardware performance in order to train your model. And if you have more money, then spend more buying more GPUs and more machines, and then you can speed up your training, so you can get the result much faster, and you can think, okay, I got some errors, and you have some feedback, interactive in training, which is good for you. Okay, sometimes models maybe because very big, and your model doesn't converge. So please do the transfer learning. Okay, and fine-tune the pre-trained model, just only focus on the n-laced layers. And sometimes your learning rate is too high, so lower it, or just increase your batch size. Okay, deep learning in the fashion industry. Our customers are worldwide, and we offer different solutions for them. Okay, and here we have 4 solutions: auto tagging, similar item in the retrieval within the catalog, or take a picture and shop in the catalog, or our recommendation system. And these 4 products require an integration pipeline. Okay, what does it mean? It means that here you have an example of some customer catalog contents. Okay, this one is the ideal image. This one is zoom in. You are not interested in it. Here you have one image that has a model with several fashion items. You don't know what we sell in this product. Here we have another no fashion item. So in this image and this image, you have discarded, just it, no problem. However, we are interested in convert this image into this one, this style, where uniform background, good illumination, and but however, we have to figure out what is selling this product. We don't know it, okay? So right now I will focus on how to solve this problem. In general, custom catalogs contain some text product text in the description. Here, as you can see, it's saying it's the shorts, denim, shorts again. So you can imagine, okay, this image is selling the shorts. So we can use both information in the neural network. Okay, here is the standard neural network for the image classification, and here we have another neural network that the input is text. But here we have word-to-vector techniques in order to convert the single strings into vector of numbers that contains contextual information of the text. Sorry. Here also, here we try to map the image feature to the text features in a semi-feature space. So at the beginning, you will say, okay, I have the short image and I have short description, but these two features must be in the similar feature space, very, very close. In order to achieve that, you will need Siamese loss, for example. So what is Siamese loss? Siamese loss formula appears here. Okay, when the pair is positive, it means that the shorts, this image match with this text. In this case, the y here it becomes to 1, and the Siamese loss we focus on this square here, these terms. When the pair is negative, when the image is different than the shorts, okay, the Siamese loss will become these terms. Okay, where the m is the margin and the d is the metric function in the embedded space. In this case, this Euclidean distance. In order to understand better graphically, it says that, okay, for the positive pairs, you try to push these points, these pairs, within this circle with the radio of m. In this case, it's the margin. Okay. For pairs that are negative pairs, you want to push out to this circle. The idea behind of this formula is like this. Okay. Right now, I'm going to present three approaches to solve this problem. Okay. The first one is just add text, fit text to this neural network, and take the entire images to the neural network. So probably these black shorts must be very close to the distant text features, and this blouse and this blazer maybe must be far away of these text features. The approach B is very similar to the A. Instead of fitting the original image, we just crop, okay, crop around some fashion items, okay, and we fit these crops to the neural network. Okay, these crops are generated by rectangles, and these are actually rectangle bounding boxes, and these bounding boxes are generated by H2Box. This method you can figure out this. For more details, you can figure out in this paper. The H2Box, what H2Box does is this system thinks maybe in these bounding boxes contain some specific thing that you are interested in. It's not no generate bounding box in the background in the background texture. They generate the bounding box that he thinks, okay, here there is something. Approach C is equivalent to the B. We use the same technology method to generate the bounding boxes, but instead of feeding the crop directly to the neural network, we feed the original image. From here, we extract feature maps. Okay, from here, we feed the original bounding boxes, and we focus on these regions in order to extract features. Okay. This layer is called ROI pooling. ROI pooling is like a max pooling, but focus on the ROI of interest. That's why they call it ROI pooling. For more information, you can figure out in this paper. Okay. And yes, the evaluation setup. Okay, you take an image, you generate n rectangles at different locations and different sizes of the image that the system thinks, okay, here is something, and then find one of n that fits with the text and also has enough overlap with the ground truth. So there are two requirements. One, the feature vector, the image feature vector must very, very close to the text feature. Also, the crop of this image must have enough overlap with the ground truth. Okay, and the metric that we use in this case is recall at n. In this case, n is 1, 3, and 5. And here we have the result. Okay, for the approach A, we could figure we achieve almost 22% of recall at n equal 1. It means that you take the crop, the rectangle that best fit with text, but also should have enough overlap. In this case, only 22% in our data set. Change approach A to B. Instead of original entire image, we use the rectangle, the bounding boxes. We could achieve almost 2 times better. And instead of changing B to C, by using the Roy pooling, we could achieve a little bit. Okay. And internally in our company, we have similar approach, but tuning some parameters and the layers, we could achieve almost 91%. Okay. The human performance that I think this task for a human task, I think they will do very, very well job. Let's say 100% or 99.9%. So this gap of the current result that we have in our company, 91 to the human performance is almost, let's say, 9 points. I think is just adding more data and change a little bit the neural network, we can achieve this the human performance. Okay. And yes, these 3 approaches were presented in this paper, multimodal embedding for main product fashion detection in fashion. And this paper won the best paper of computer vision for fashion workshop in ICCV 2017, yesterday. They notified me, yes. And yes, in order to achieve this result, we spent a lot of time doing many experiments. So speed up the experiments will be great for you. So after learning this neural network and we map the image features in 2D, we can see that there is some clusters like trousers, shoes, and upper body stuff, and some bags here. Okay. So yes, this problem we solved. Okay. However, for product 2, 3, and 4, required good image retrieval. Okay, it means that the system must rank the result based on the visual similarity. And so, what is the visual similarity? Here is an example. Here it is the query, this kind of shoe, and this sound result. They are visually similar. Why? Because they have heel style is similar, and a heel height is very similar to this one, and open toe, but tie style and open heel are not similar. This one very similar to the query, however, except the color, and so on. So color, shapes, patterns, and style matter, yes. But what if I show this result? These results are very similar to the query. However, the branch is different. Sometimes some customers say, I prefer that you return me only Nike shoes. Even the visual similarity are no okay. So what about the brands? It's a hard question. Okay. So to measure the visual similarity, we need to measure the average human perception of visual similarities. So in order to do that, you have to spend a lot of money in give the images, and people annotate the data, and you measure the agreement between the different annotation decisions, the agreement between the similarity perceptions. We can use the kappa metrics. It's expensive. I think it's worthy to understand what is the average visual similarities. Okay, and in order to teach the neural network to rank rank the results according to the visual similarity, you have to add some ranking loss. In this case, for example, triple loss. Okay, you say, okay, the similarity of these shoes is much higher than similarity of this pair of the bag and this shoe, if the query is this shoe. Okay. In my opinion, visual ranking is still a hard task and open problem, because the visual perception of the results will vary a lot to the number of products that you have in the catalog. Imagine that you have a catalog of 1,000 products, and compare with one catalog of 100K. Probably in the bigger catalog you can find much better results, because the products in the feature space, they are very close to the query, and it's very easy to figure out what is the similar to the query. But in the sparse space, because you have 1K products in feature space, it's a bit sparse, and sometimes you cannot find the similar product. Let's take an example of this. Take a look at this example. This is the input image. This is blue shoe. Okay, the distance of this shoe to this shoe, and distance of this shoe to this shoe, maybe in the feature space, is very, very similar. However, if you return these results, show to the customer, hey, this is the similarity result, they will say, oh, this system doesn't work. So sometimes it's hard to work with a small catalog, because there is some specific cases that you cannot solve it. Okay. So the summary is, deep learning is cool. You need human performance to understand where you are, how far you are from the human performance. Because if you are you are close to the human performance, maybe you are not interested in improve your technology. Okay. Otherwise, you have to pay a lot of money and train many models to do many experiments to achieve the human performance. Obviously, you have to set up a baseline to understand where you are, and yes, do many experiments in short periods if you can. And that's it. Thank you. Okay.
Okay. Thanks, Long. We'll take the questions later. So let me introduce the second speaker for tonight. Aleix is, we know him from a long time. He was one of the co-founders of BCN. And, oh, better. Let me start again then. Aleix is, we know him from the beginning of BCN Analytics. He co-founded this association, and he's been he's been active in many different companies. But just to summarize his background, he's a PhD in mathematics. He's applied machine learning to many different areas: transportation, media, especially on the online side, and retail. And now he's the chief data science at Onna, and he's responsible for developing and putting in production machine learning models for document management. So he will be telling all about it. For those of you more on the technical side, he is also running the R users group in Barcelona and the machine learning study group. So if you go to these other meetups, you will be meeting him all the time. So with no further delay, Aleix, the floor is yours. So thanks for coming.
Hola. Sí. Hi, good night. Thank you, Pau, Manuel, and Tim, and Manuel, for inviting me again. Well, this time as a speaker. I'm going to explain what we do at Onna. I hope you like it, and then ask as many questions as you feel. Don't be shy, and you can ask almost everything. The first thing is, what is Onna? Onna is a software. It's a platform where you take all the documents from these sources, which are the usual sources, and you put them together inside the platform in a way to ease the users find and search documents inside this platform. Our focus right now is in the law companies because they have like lots of contracts with all the details, with lots of information, and they want to find documents and that satisfy certain certain conditions. Sorry. And they may want to look at similar contracts, contract with the same people, and all this kind of stuff. This is what ONA looks like, the ONA platform. You can see here you have a search bar. You have many data sources. You can select the ones that you want. Here is the filtering. You can filter documents. All this platform, it's built upon a software, upon a library, Python library that's called Guillotina, that we are very proud of because we developed and we also open sourced it. It's in the Plum community, which I didn't know before, but it seems like it's a huge community. And well, it's something fun to be in a company that open source their code. That's always, well, it's not always good, but it's good. These are our current customers. ONA has 2 offices, one in the States, in San Francisco, another one in Barcelona. The technical office is in Barcelona, and the commercial office is on the States, which is a very competitive way of organizing that. We are 15 people, more or less. Okay. What we do, or what we've been doing, I've been there for a month and a half, so I'm quite new in the company. I cannot say like a large experience there. But our main goal with machine learning is to help the users find better what they look for. These are the types of problems that we are dealing with. The first one, which is the easiest one, it's you upload a document and automatically tells you what type of document it is. Is it a warrant? It is an NDA? And lawyers can use it to filter. Then look, okay, tell me all the NDA contracts that are on this range of dates or whatever. This is a pretty straightforward problem in machine learning. It's a classification problem, which is not that hard. The second problem that we have, it's quite related to what Long said. It's to differentiate between what are contracts and what are non-contracts. He said that he has some images that he rejects. We have the same problem. People can upload any document, so we don't want to classify documents that are not contracts. This is like a technical problem. It doesn't seem like very interesting, but it is quite interesting because you only have contracts. You don't have what are non-contracts. You want to build a classifier that it's based only on contracts. And if you know what a contract is, can you say what it is not? So it's not that easy. Some things that we are still working on, it's improve the search bar with something more intelligent than just documents that have this keyword, for instance. What we are also working on, and it is quite a feature for us, it's that the user can train their own models in the sense that they upload documents labeled somehow, and the platform has to build a classifier that tells new documents what they are, but in an unsupervised way. I mean, it has to be automatic. So it's not only a problem of how modeling, but how to implement all different infrastructure to do that. And the last one, and it's probably the most difficult, is to get the more information that we can from the contacts, like which persons and companies are involved, dates, quantities, and so on. Okay. As Long said, and as the hype is right now, we are basing our infrastructure and techniques in deep learning. Why? Because it has a very good results in text and imaging. This is accepted by almost everyone. it also handles many ways of inputs and outputs. It has like a very flexibility to deal with different types of problems and areas. You can do with deep learning, you can do classification, ranking, you can do recommenders, and you can do like a lot of variety of things with the same technique. And that's a very, very good thing. We are basing our infrastructure using TensorFlow and Keras. TensorFlow is an open source library that Google opened, and it's very, very popular. And Keras, it's like a library for making your life easier. And when we train a model, we put in production, and we use something called TensorFlow serving. That's a technical thing, but it's pretty fast. Our main difficulties are, right now, some of the things that we want to do are pretty well solved. Like classifying documents, it's something that it's straightforward. But some of the things that we want to do are not as well known, or maybe are not really solved. So there's like, okay, let's do a model for this. You do it, you get it, and you have it. And let's do a model for that. Okay, I need like 2 or 3 months for that. And you don't know which are the results that you can expect, and how is it going to work. That's very interesting, but it's hard sometimes. And in the long term, there's the thing that we don't know how deep learning will evolve. Deep learning is one technique among a large corpus of techniques in machine learning. So when deep learning will get stuck, we will go to other techniques. But deep learning right now, it's letting us to do things that we didn't think we could do some time ago. So maybe in 1 year, deep learning gets stuck and we don't get better models. What we do is what we are having right now, and that's all the story. Maybe deep learning will evolve for 10 years or 5 years or whatever, and we can do like amazing things that are very similar to humans. But we don't know right now. And our performance depends hardly on this, besides our capacity to do that. And about my experience working with machine learning, this is not only from this company, of course, it's from the rest of the companies that I've been working also. The first thing is something that I like to say and I like to think. What I say, it's wrong, but some of the things I say are useful. This is in fact, took from statistical literature, a well-known phrase from many years ago. But this is the kernel of machine learning. Machine learning doesn't worry if models are good or bad. Machine learning only worries if models are useful. And that's something that is different from traditional statistics. So again, what I'm going to say, I hope it's useful, but it's not good or bad. The first thing that I think of, it's complexity. For me, the main problem, I would say the main problem of the world, but it's not the main problem of the world, but it's like a huge problem. It's complexity management. This is a traditional picture from machine learning. The dots are like the data that you have. The dashed line is like the model that generated the data, or the true model, or whatever you want to think about. And the solid lines are the model that you apply to describe this data. Okay, so in machine learning, you build a model to describe the data. But what you learn in machine learning is that for every different problem, you have to adapt the complexity. It depends on your problem and on how large is your data set. And there are not models that always work for everything. No, for each problem that you have to adapt complexity. And this is, again, the kernel of machine learning. And I think it's something that we can really get from it and apply to all different areas. In that sense, it's not talking about only about models, machine learning models, but you can think about what techniques of machine learning are you going to use. For instance, if you do deep learning, but you could use logistic regression, then you're doing it wrong. But basically, if you can do it simpler, then do it simpler. But if you have like a very complex problem and you need deep learning, then apply deep learning. There's no uniform solution for everything. The same holds for your technical infrastructure. How many companies have applied and built and paid for big data when they don't really need that? I mean, that's a real problem. They think that, oh, let's buy something very, very complicated. But if you don't need that, don't buy that. I mean, it's quite simple, but it doesn't work like this. I don't know why. On the other hand, if you have lots of data and you have a personal computer, then maybe you have to think about increasing your infrastructure. And the other level that, for me, it's interesting to think about, it's the team organization. You can have teams with large variety of profiles, or you can have teams that you want them to work all in the same way uniformly. There are companies that want to have all the workings like do the same or in the same way, and there are companies that are quite loose and everyone does whatever they want. So for me, it's a complexity adjustment problem. It depends on your problem. You may need like a diverse team, or depending on your business, you can work with a very regular team. So it's something that for me it's interesting. And the other thing that I think that it's also really interesting, it's the focus between exploitation and exploration. I like this way of exposing that because I had like many problems with the IT departments. Everywhere I went, I had problems with the IT departments. And you start to fight, and no, you have to do that, and they tell you, well, you start to fight, and it's all a mess. But at the end, I thought that depending on the IT department, because again, not all the companies are the same, but the companies that I found, not the last one, I have to tell, I'm very, very happy with that. And it's true, it's true. It's not IT department, it's a way of thinking. If you're worried about exploitation means to repeat something that you already know. You repeat it many times to get a profit. Okay, you're working in a place that you know what to expect. And exploration means try to discover things that were unknown for you. Exploration can be learning a new language, learning a new technique, trying new ideas. And the thing is that it's not an activity that it's for just one department. All this exploration and exploitation are transversal to the whole company. But some companies need more exploitation and some companies need more exploration. And since we have new techniques and we have new scenarios, in machine learning, there's a lot of movement and changes. And it's something that when it comes into the company, sometimes doesn't fit really well. So companies, they hire like machine learning team, but they put it there. You have your laboratory, and things don't live from here and go into production. That's a big problem. So the differences between exploration and exploitation, I put it here. The first one was, it came from the relation with the departments. But why you should explore or exploit? Well, the first thing is your environment, okay? So if you are working in an environment that it's very stable and you think what to expect from the future, maybe with exploitation it works for you. But if you're working in an environment that changes, and I think that socially right now it happens, you have Google and Facebook that they are changing all the time, then you need exploration, sorry. there's also the focus between short-term and long-term. It's very easy to stay all the time thinking in short-term because you need to earn money to eat and you need to exploit things to survive today. But if you don't think what is going to happen in 2 years, 5 years, or 10 years, maybe you will have not any margin to move. So exploitation is more related to the future somehow, and exploration about the future, and exploitation is more related to the now. And the other thing is that it's very easy to see that someone takes a problem and solves it, but at some point you realize that the best way of solving a problem is not having it. So for that, you have to make some prevention. You have to think about it, and you have to start to think it now. And that's what exploitation tries to do. And it's a way of thinking that it's somehow theoretical, but it helped me a lot dealing with people and understanding that they were thinking right for now because they had a problem right now. But trying to explain these kinds of things made a little bit easier my life. And that's the things that I value most from my experience. And well, that's all. Thank you very much.
Thanks, Aleix. We'll be taking questions in 2 minutes, so give us 1 minute just to bring the chairs up, and we'll start the debate. All right. Okay, so I'll start because I have the microphone, but I'll be asking for questions in the audience in a minute. So I'm not very good at documents, and I'm not very fashionable myself, so I'll be very bad with the examples, but I'll try to make myself understood. Both of you are trying to help users find things, and both of you are building vertical solutions that are very good at one thing or one sort of very close things, yes? So, so probably it's easier to describe in fashion, but I think that we can do also the extrapolation to products. So basically, if I'm trying to buy something to wear, yes, and yes, as I said, as you correctly said, with text, it's extremely difficult. I wouldn't know where to start to say I like this kind of clothing or whatever. So yes, I agree that it's a good idea to start saying, I like this, or I start looking and I like this, and then pulling the thread of similar things is a very good way to start. But in the end, my question is, do you see your solutions going in this direction, or do you see some other companies doing this based on your feed? Meaning, you see that there's still a lot of work to be done in finding similar things by the way they look, or you see your engines evolving into something like, I see a shirt and I say it's too tight, it's too baggy, it's too, so from the attributes that you built, that we could engage into a conversation in which your engine, is a personal shopper that can answer smart things and with the same inputs that you have. So yeah, so it's like, oh no, I would like something a bit more, I don't know, more tight or whatever, or the color is too bright, and then that you can say, oh okay, so not only showing things that are similar, but out of the things that are similar that I could tell you a little bit in a human way, what is it that I'm looking for? So the question is, do you see this, or your focus is image, and then somebody else will build this on top? And likewise, I don't know how to translate this into contracts, but say I'm looking for a contract that is not too wordy, that it's that manages this, and so that you can improve the search.
Am I making sense?
Yes.
Okay.
Okay, I start. Since our company is B2B, okay, we offer SaaS. So it means that we deliver API, some definition, you put some parameters, and we return back some results. In this case, the result of a list of images that is similar to the query. So after we deliver the result, and beyond this, we don't know anything. So we don't know the user preferences. We don't know. And our customer, the e-commerce platform, they have to understand how to use our API in a smart way to have us a little bit of conversation with the users. So in this case, we can now create API smartly according to the preferences of the user in the real time, because we don't have this user level information. And also we think it's a hard negotiation with the customer to, hey, give me more data. Oof, I don't know. So let's enter to the negotiation. But at the beginning, right now, we just only offer API, and beyond this, we don't know anything.
Okay. And sorry, and still in the API, and getting some feedback from what are your recommendations. This is off the. So for instance, I'm finding similarity, but as you said, there is similarity meeting certain criteria, not meeting certain. So is there any feedback so that you can say things like when I'm not incorporating the brand, or when I'm not taking into account how important is color with respect to shape? Is that somehow?
We cannot solve this problem. I think our customer must understand. Let's say they should have a data scientist to understand what their user behaved, and according to this, they tune some recommender system, and then use our API. Yes. So right now we focus on the promo of street to shop. This means that the people on the street, they take a picture. So the pictures are taken has wild conditions instead of uniform background, good illumination as the catalog images. So we are transfer some, the wild style into the ideal world. This is the quite a challenge, because you don't know what happened in the real world. People sometimes take a picture and, okay, I want those shoes that is there. A super small piece. Sometimes it's hard to figure out what is the shoe he's looking for. Yes.
I didn't understand fully the question. The thing is, if you get the feedback from the users, if you want to take into account, maybe ask questions to the user, something like that?
Something like that, yeah.
I don't think we are thinking right now about doing like dialogues or something like that. But if the user can train their own models, and they have like rejection, like, no, this is not currently done.
So this is a little bit going in that direction in a way.
Yeah.
Okay. Questions? Okay, so do we have, 1, 2, 3, do we have a microphone? So we'll start there at the back. Please say your name and...
Thank you very much. My name is Carlos Maggi. Thank you for your presentations. And my question is concerning to textual treatment. Both of you use it. And I understood Lung Lu talk about word-to-vec. But my question is, are your platforms and your solutions language independent, or you need to train different models for every single language? Thank you.
Okay. I start. Okay, good question. Actually, we have this kind of problem. Our model was trained with English language, catalog of English language. And yes, the model only understands the English language. But I think there is a framework in Facebook that can map the different language words into English word feature space. So if we could use this framework and just transform the different language into English word, and we can use these features in order to to train our model that solved our problem that I presented in this speak.
In our case, it's language dependent. Right now we are building for each. Well, right now we are just only in English, but we will do for each language separately. Maybe you can try like translate the text and then apply, and maybe it works. We have to just try.
We had another question here. Oh, sorry, first line, yeah, here. And then there was another one, so here. I know one at the back, yeah. Okay.
Yeah, hello. It's a question for Longwoo, yeah? It's okay, okay. So it's about how your engine works or how you build it in terms of difficult examples. Like, for example, if you have different patterns, different colors, for example, you compare similar patterns and then this is the same, or is the pattern is the same but colors are really different, then you choose similarity by color, for example. So it's the same a really huge flower compared to little flowers, but it's the same flower, or not? Little flowers are more similar to dots, and then, so these kind of difficult examples, when you have patterns, pictures and things like that, how the engine works, and how do you decide which is the correct solution?
Okay. You know, the deep learning is a kind of a black box, and you put an input and you put output, and you say, hey, I want this. You have to predict this the output that I deserve. If the output is wrong, and update some parameter in order to achieve this output. So deep learning is a little bit a black box right now. So in order to teach the neural network to rank which is the similar, which item must be in the top of the list of the according to similarity, we just use the annotated data and say, hey, this is the similar, and the system learns. We don't know too much if the neural network is taking more important to the pattern or to the color. I think this is your question.
Yeah.
Okay. And also, we train the model on the neural network, not only focused on the ranking, also we train the model at the same time with the attributes in prediction. So this model is quite big, and it is multitasking neural network. So the different attributes losses can contribute with each other, and so then they can, at the end of layer of the neural network could have a lot of information about the attributes and then also the ranking. So yes, we do this kind of neural network, and it works, and we don't know if it's taking more into account the pattern and color. But if you evaluate your model, and you analyze all the results that you have, you can see the correlation between the colors and the pattern or categories and or other attributes. You say, oh, it seems that this neural network is taking more into account patterns. So, you know, maybe you are not interested in the patterns. Okay, so you can you can put some weights to your gradients. So, okay, you can, instead of 1, you can, let's say 0.5. So the network will learn will lower information about patterns. So in this case, it's a bit of analyze the result and change some weights to achieve what you want.
Okay, thank you.
We had another question here at the front row.
Hello, my name is Ramon, and I have a question for Aleix. Regarding your long-term concern about how important is going to be deep learning in the future, I would like that you could build a bit more on this topic. And I am not sure if nowadays, thanks to computers, we are just taking advantage of a lot of mathematical knowledge produced a lot of years ago, because deep learning is nothing developed now. And maybe as time goes by, we are running out of, so the production of this knowledge in the universities is increasing in a decreasing rate. So we will run out of ideas to exploit in the coming years, or in which situation are now. We are producing new techniques, to substitute the current ones, or how is the future looking?
Deep learning, neural networks started in the 70s or the 80s. And they were used, but they weren't really popular. And they got stuck for some years, and then with the current computers and data, they were used again, and they were like rediscovered. But you don't know how much this is going to take. And I don't think that we run out of ideas, because there's lots of people involved and lots of resources. So it's not a matter of resources, but it's a matter that, the technique was there, and until some point it doesn't took disadvantage. So naturally the technique has its limits, and you don't know where they are, and we will find them. I don't know if somehow if it answers your question or not.
Are you producing new techniques like deep learning was produced in the 70s and the 80s?
Yes. In fact, every time there are more techniques, and deep learning is one area, but there are lots of other areas in machine learning that are growing in parallel. And right now they are not really that important, but maybe in 10 years will be the main hype. And 10 years ago, there was not neural networks, there was super vector machines or boosting or whatever. So there are growing lots of areas in horizontally and vertically, and the community is growing, and the people doing research it's growing, and the conferences are exploding. So it's not a matter of people, and it's not a matter of areas. I don't know if it's, but the techniques have their own limits.
Okay, Mauricio, there was a question there on the left.
Okay, hi, my name is Alejandro. I was wondering for long,
yes.
And now you have a very good framework for fashion. Have you thought about applying this to a different kind of product, like cars, vehicles, furniture, something like that?
Do you mean at company level or at personal level?
I was speaking about anything. Any, for example, if you have tried and you have like a general idea or thought about it?
Well, at a company level, I would say no. we are super vertical, and as I said, in deep learning, by using deep learning, you can use the transfer learning. You can take a pre-trained model. For example, in the model that uses ImageNet dataset, you have a good model, super optimized parameters, and just fine-tune the latest layers with a few number of data. Probably you can achieve some good results in your test dataset, but you still have to evaluate in your real-world test dataset to understand where you are. Mm-hmm.
Okay. There was yet another question on the left.
Hello, my name is Parinos, and I wanted to ask that you said for training this kind of deep learning model, a large amount of data are needed, and I wanted to ask that how many data, how many images approximately you use for training the model, the deep learning model you have for topic, for fashion topic, and are there label data or not?
Okay, you were asking the number of data that we are using. Another question was there?
Were there labeled or unlabeled?
Okay, well, we have both. We have a lot of data, a lot of images, let's say images, we have a lot of them. And not all of them are labeled. So we are working on about 1 million of the images. Well, let's say 1 million of labels, because one single image has several labels. Let's say the category of the categories and the colors. So we have 2 labels, right? So right now we have around 1 million of the labels, and this at the level of categories, okay, the attributes. Then we have also we do object detection. So okay, so we have many annotation about the bounding boxes, the location of the fashion item in the image. Also, we have this kind of data. We have a lot. Yes, we have also have a lot of data and that are not labeled. But there exists a method that you can learn from the unlabeled data, which consists of you first train your first model by using the labeled data. You have a model, and you take all the rest of the images that you have that are not labeled, and you infer. You put these images to the networks, and you have some probabilities, okay? And you can use many different models in order to improve your performance, okay? And then you take these probabilities as the ground truth, and then train a smaller network and try to copy what the big model does. Copy all this inference and train this small model. So right now, you are taking unlabeled data, but using the synthetic label generated by your previous model. So this kind of technique you can work. So I think I reply your question about the number of data, and also we have how to use, get leverage on, get benefits of unlabeled data.
What is the name of this automatic labeling of data technique?
I don't remember the name of the paper, but the author, one of them is Hinton, the Geoffrey Hinton. Yes, it's distill something. Yeah, if we want the name of the paper, after I can share.
Thank you.
Okay, there was a question at the back, yes, and then here at the front.
Okay, I am Eduardo, and my question is for Loom 2. You have shown us a model where you combine the information from the image and from the text description. And I think that the model for the text is much more simpler than the model for the image. Okay, this is about complexity, or because the description carries less information than the image itself, or why? Why the model is more simple?
Why the model?
For the text. For
yes,
the text.
Why is it smaller?
Yes. Why don't a recurrent neural network or something like that?
Okay, it's well, this paper, all these experiments have been done in last year, 2016. In that moment, we were still using Caffe.
Yeah.
And I remember that in that moment, Caffe doesn't have recurrent neural network.
Okay.
That's why we didn't use the recurrent network. Right now, we are using PyTorch.
Yeah.
And well, since as I told you, since the current method works,
yeah,
we are not focused on improve the technology, because that doesn't make sense. So we should focus on the technology that doesn't perform as the human does, right?
Okay, thank you.
There was a question here at the front.
Hi, my name is Awan, and I have a question for Longlongyu. So you have, in your product, you have actually different solutions, right? One of them is the street-to-store option, and another one is some kind of recommender systems, right? Have you thought about combining somehow those two to give a new kind of insight? So let's say I have shoes at home, and I would like to find a jacket that would suit well with my shoes. Have you thought about that kind of solutions?
You mean automatically figure out the outfits that you are interested in according.
Exactly. So this is not a question of similarity to the item I'm sending, but finding something that would fit with.
Actually, we have this solution for the Inditex group, and we use their catalogs to generate the recommendation, because their requirements is so high that we have focused in their outfits. Okay, this is the yes. We are doing this kind of solution for the Inditex group.
We have one last question, and then we go to the networking part. So.
Hi, my name is Adriana, and thanks a lot for the presentation. And it's interesting the fact that you're doing like an Inditex. I like it. One of my questions was like, Desigual Inditex, you probably work in different scenarios. But by being an API, you're not retrieving the information from what the user like after you offer the recommendation, because I think his question was more related to that. If you could create a model that based on the picture and the picture of the person, based on what the Inditex people respond to your recommendation, you can even generate one level more, people that like this also like that. It's the way Amazon works out. But my question is more little deep on the sense of so for example, for Aleix, for you to go for the medical side, from legal to medical, you need some changes. And for you to go from Desigual to Inditex, you also need some changes on you guys, how you guys perceive that is easier or harder to do those.
I start. So let me think about your question. You asked for how easy to change from one technology to another one. No.
From Inditex to Desigual.
By using the same technology.
Yes. Because Desigual is all colorful. Sorry to say that. I don't know if you know Desigual. Well, in Uniglow and Desigual, one has colors and the other one.
Well, since we are using more than 1 million images and label data, I think our model covers all these kind of different styles, let's say. Yeah, I think for Desigual, the system will work better because the floral patterns, if you look at floral, everything's floral. Wow, they are pretty good in the human perception. Yes.
Well, in fact, it's something that Long said before, that with deep learning, there's a way of, there are many layers and you can keep some trained layers, so you can start from those with new data. And if you're lucky, those layers are have some information from one hand and you can apply it to other areas. So probably that's the way.
Okay, so two things. One, thanks to the two speakers. I thought it was very interesting, so thanks for coming. And as you know, we have networking session with free beers and water here on the left-hand side. We will need to leave at 10 minutes to 9 sharp. So when they turn off the lights, please get out of the building quickly. Okay, thank you very much.